In this video, I'm excited to discuss solar's integral role in solving the climate crisis. What is the climate crisis? Due to us humans emitting large amounts of greenhouse gases, also known as carbon dioxide and methane especially, these gases trap the sun's heat on Earth, leading to an increase in global temperatures. This phenomenon is called global warming or climate change, since increasing the global temperature significantly changes the climate around the globe. As shown, the Intergovernmental Panel on Climate Change, IPCC, models how much the climate changes for 1C, 2C, and 4C global warming. With each scenario, there's a higher mean temperature, leading to consequences that include warming the Arctic and Antarctica, that will melt glaciers and ice, leading to raising sea levels. Here we see 1C, you have some temperature change at the Arctic. Then you go to 2C, which is more significant in the Arctic for temperature change and also areas of land that are increasing in temperature change. And then finally, 4C, where you can see the Arctic and Antarctica area, so both poles, are increasing in temperature change significantly, as well as many areas of land around the Earth. And so, in addition to this, you can see the mean precipitation change for 1.5C global warming, where the poles have an increase in the mean precipitation change, whereas areas near the equator are drier. You go to 2C global warming modeled, and you see that around the subtropics it's drier, and as well as the poles have increased in mean precipitation change. And then finally, for 4C global warming, you can see the poles have even higher mean precipitation change, as well as many areas of land that are much drier near the equator. And so from this modeling, as well as information with understanding how global warming and the temperature change impacts our climate around the globe, the United Nations also began to meet to understand how can they limit the global warming impact. In 2015, the United Nations Paris Agreement was a significant milestone in which hundreds of countries' leaders committed to limiting the change in global temperature to 1.5C by 2050. And so there's two questions that come from this. Why 1.5C versus 2C, which was a previous climate goal for limiting global warming? And also, how can we achieve this 1.5C goal? Scientists state that limiting to 1.5C will prevent the worst effects of climate change. So let's try to understand this first through the World Resources Institute report. For the global population, it is exposed to severe heat at least once every 5 years, if for 1.5C modeled to be 14%, versus 2C, which is 37%. So about 2.6 times increase in population impacted by severe heat for 2 degrees Celsius. And so this is a significant amount. A third of the population is going to be exposed to severe heat if we continue to go to 2C, and this would happen at least once every 5 years. For the number of Arctic ice-free summers, at least once every, for 1.5C, 100 years versus 2C, which is 10 years. So a magnitude difference. For the amount of sea level rise by 2100, for 1.5C, this would be 0.4 meters versus 2C, which is 0.46 meters. And so this average amount is going to vary per area of the Earth because different areas of land will have different amounts of sea level rise, and a significant number of communities near the coast will be severely impacted, leading to areas of land that are not livable, areas of land that would lead to communities being destroyed. For coral reefs, there have further decline if we have for 1.5C, 79% further decline versus 2C, which is 99%. Currently, we on Earth are on the path of more than 2 degrees Celsius warming if we continue the way we emit greenhouse gases into the atmosphere. This would mean that we would have even more destruction of coral reefs than 99%, as according to the modeling from the World Resources Institute. And so this means that many, not only coral reefs of fish that are living in these ecosystems are going to suffer, but also tourism. Economies around the world that really depend on tourism of coral reefs are also going to suffer. In addition, we have decline in marine fisheries. for 1.5C to be 1.5 million tons versus 2C, which is 3 million tons. And so a 2 times difference, which is very significant as this would impact what food that people eat, as well as the economy and jobs that are around these fisheries and these industries. And so with this information from the World Resources Institute, now we know that limiting to 1.5C warming is very important. With just a difference in 0.5 degrees Celsius, you can see that there's a significant impact on not only our daily lives, but also the communities around us and our future generations. So how can we achieve this 1.5C goal? The IPCC modeled 5 scenarios that vary the amount of carbon dioxide emissions to the atmosphere and the corresponding model change in global surface temperature. As shown, only the 1.9 option achieves our 1.5C goal by 2050. If we limit to 2C, however, our only other option is the 2.6 option. So what is the 1.9 and the 2.6 option? The 1.9 option, reaches about net zero emissions by 2050, and then net negative carbon emissions afterwards. The 2.6 option, however, reaches net zero by 2075, and also net negative carbon emissions afterwards. So this means that we need to reach net zero globally in about the next 20 years. Here we also see the different major greenhouse gas emissions that also need to be limited or stagnant to achieve our global climate goals. Okay, but how do we achieve net zero? Part of the answer to that is to replace most or all dependence on fossil fuels in order to get to that net zero goal. This is where solar and wind come in. From the International Energy Agency, IEA, to reach net zero by 2050, we first need to increase solar and wind up to 4 times more capacity by 2030 compared to that of 2020. So from about the 200 gigawatt range to the 1,000 gigawatt range total of solar, PV, and wind. In addition, according to the IEA, we need about 24,000 gigawatts or 24 terawatts of solar and wind capacity by 2050 as shown. Further, as shown in 2020, our total generation from renewables is 29%. In 2050, this grows to about 90% to achieve net zero emissions. And so this shows that we really need to improve wind and solar dependence in order to achieve our 2050 goals for net zero emissions, which would then lead to limiting the 1.5C global warming goal. Renewable energy, and in particular solar, is integral to our solution to replacing our dependence on fossil fuels. From many different studies, there are varying numbers for how many terawatts of solar is needed by 2050 in order to achieve our net zero carbon goal, as well as to further increase our dependence on solar for our future energy resource. And so from different papers, it's been 24 to 70 terawatts. Here we see from the IEA that they have modeled to 70 terawatt hours of solar by 2050 to achieve net zero carbon goal. There's also a different paper that has stated that we need 70 terawatts of solar capacity by 2050 in order to achieve our net zero goal as well. And so there's variations, but in the end, we need multi-terawatt solar by 2050, and in particular, replace the majority of our energy use to solar and wind. And so if we have 70 terawatts of solar by 2050, this would mean that we need 6 to 10 kilowatts of PV per capita and an annual PV production system of 3 to 4 terawatts per area by 2050. So is this possible? Here we see the capacity increase needed by 2030 and the predicted trend of solar PV capacity by 2050, all modeled from the IRENA renewable energy statistics. Here we see that we can get up to 8.5 terawatts of solar by 2050, which is not enough considering that in previous models it's been 24 to 70 terawatts needed by 2050 to get the net zero emission goal. And so we need to really improve this capacity for the future. So to reach the multi-terawatt total that we need installed for solar, we need to increase the solar device efficiency significantly in addition to reducing costs, such as installation costs, soft costs, and manufacturing costs. In particular, the PV industry needs to increase its annual production by a factor of about 30, and in the past 60 years, the PV industry has doubled its capacity on average while reducing manufacturing costs by about 10 to 16% per year. With this information, we can work towards reaching a terawatt goal of, say, 70 terawatts in order to achieve net zero emissions. And so we can improve efficiency by exploring new materials and developing large-scale multi-junction solar devices. However, for reducing manufacturing and installation costs, we need to also think of new ideas. This schematic shows the weight of materials needed to manufacture solar cells, with glass, steel, and concrete consisting most of the manufacturing materials required. If we can significantly decrease these manufacturing materials and reduce soft costs, while also achieving efficiencies on par with silicon, simultaneously we can deploy solar more efficiently and achieve our climate goals. For example, with space solar, automobiles, and building applications, to power these with solar, we need high specific power or high power to weight ratios. This means that the weight matters. And so having lightweight materials while also having efficient devices is necessary for these niche applications. This is where we need to improve. Reducing material use while achieving high power generation is necessary to have solar be cheaper while also widely deployed. Here we see the critical materials and minerals that are necessary to achieve net zero emissions in solar cells. And so we need to consider these critical materials, how we can source them, as well as veer away from rare materials such as silver that would increase the cost of our devices. So we need to think of new ways of manufacturing these solar cells such that they can be cheaper manufactured as well as widely deployed. Therefore, solar is important from the information that we learned today and integral to our net zero climate goal of achieving a limit of 1.5 C warming by 2050. However, solar is only part of the solution. We need to not only decarbonize our economy, but also educate the public and actively preserve and protect our natural ecosystems, such as the coral reefs, rainforests, and the Arctic. If we don't achieve this by 2050, we face dire consequences, including widespread natural disasters and irreversible damage to our communities and wildlife. If we want to pass on a livable Earth to our future generations, we must support and take action. To start, I compiled here are my references and then compiled additional resources, including links to organizations who are actively helping with environmental preservation, especially through renewable energy and community solar deployment. Please share this video with any friends and comment any questions that you may have, as well as any suggestions for future videos. Thank you for listening and looking forward to hearing from you all.